Hello, welcome to our presentation. The name of our project is Drone Savar. We work together with 4 people on this project. To briefly introduce, firstly, Barkan work on power electronics, then Erencan Tezel work on software design, Furkan Çetinkaya work on mechanical design, finally Oğuz Yalcin, so I worked on the antenna. We also work together during the production phase of the product. Next. Needs identification, firstly security, secondly detection and tracking, thirdly frequency mixing. Other needs are autonomous or manual control and a user-friendly interface. Next. Problem statement. We can sort the problem statement part as follows. The fact that drones are one of the main factors of wars. The increase in the use of drones by malicious people. Finally, since neutralizing the drones is necessary to ensure the security of the region. Next. Requirements. We have examined the requirements in 2 readings. Firstly, marketing requirements. The system should be easy to use, cheap, and shouldn't be complex. Secondly, engineering requirements. This system should be able to work both mobile and stationary. It should be effective in an area with a diameter of 100 meters. The minimum operating time of the system should be 30 minutes. Next. Proposed concept. We used the concept of frequency mixing in this project. The implementation of this concept will be explained in a moment. Next. When we came to the design part, we made our design under 5 main headings. These are system design, power electronics, antenna design, software design, and mechanical design. The titles that the group members are responsible for are shown in this presentation.
Hello, I am Erencan Tezel. This is our level 0 diagram. The drone jammer detects targets by receiving signal and camera images and neutralize the target with the jamming signal it generates. Our level 1 diagram is in 2 parts. The first part produces the RF unit and the jamming signal. The other part is the control unit. It uses artificial intelligence to detect the target and control motor and signal. Here you can see the circuit where we produce the jamming signal. For power electronics, we first calculate the total required power. Here you can see our AC to DC converter. We tested in simulation and achieved our desired values. We designed DC to DC converters at various voltages. Here is one of them. We test all of them in simulation again. We designed a directional log periodic antenna. Here you can see the S11 pilots at relevant frequencies. Again, our 3D polar pilots and radiation patterns are like this. For software design, we first designed an activity diagram. After we designed the necessary structure with a UML diagram to implement this diagram and wrote the code. We designed a casing that could rotate 360 degrees and accommodate the component inside. In the design, we particularly focused on cooling and dust issues.
Hello, I'm Berkan Öksüz. Let's continue with the construction phases and test of the project. As you can see in the figures, we start with building the electronic circuits. We tested our circuits on breadboards and then we soldering them. We were able to obtain the desired output. Next slide. Then we continued the test by making the connection of the RF unit. We performed the test with the receiver and the transmitter shown in the figure. At this stage, we managed to cut the signal as we wanted. Next slide. As an important point, we continued by testing the system power supply. We have obtained the desired input voltages with the buck converter and the voltage regulator in the figure. We tested the system again at this stage and we were able to jam the signal at different distances. In the next step, we build the structure as can be seen in the figures. Next slide. We test the scanning process of the antenna and the camera by placing the stepper motor inside. Next slide. In the final stage, we complete the test by integrating our AI model. Our AI model, which was developed using 25,000 photos, was used in the control of the project using a microprocessor and a stepper motor driver. At this stage, a joystick was added to the project. A relay has been added to the project to control the split the jamming signal. Let's watch the video of our test. Here you can see our AR model tests. You can see the detection rate. Here, our friend Eren shows that we can control the antenna and the camera with joystick. Again, you can see that the control signal with the relay. Then we see our electronic circuits. Here you can see the receiver is receiving signal at level 10. When our system starts to work, the signal levels dropped 0, as you can see. Here you can see that the test of our AI model. You can see that our camera, which normally scans 36 degrees, but it locks up when detects a target.
Hello, I am Furkan. The drone jammer system ensures defense to drone threats with its high sensitivity detection and rapid response mechanism. It intervenes upon detecting any airspace threat, making it ideal for protecting military bases and critical facilities. Next, please. Our user-friendly system, featuring an advanced control panel, ensures user satisfaction. With full control and management capabilities, the system empowers users to disable flight system using powerful jamming technology. This provides an easy-to-use and effective solution. Next, please. The total cost we calculated during the design phase was about 10,000 Turkish liras. Some of the products had been obtained for free. As a result of this, total cost is about 1,000 Turkish liras. Next, please. We ensured compliance with military standards like DO 178C and DO 254. These standards covers software, hardware, material selection, and power supply requirements. We also adhered to hardware and software standards shown in slides. Next, please. After product was completed, tests were carried out to verify the performance and safety and to check the expected effects on targets. As a result, it can be said that the product complies with the certification in terms of safety, performance, and compliance requirements. Next, please. Safety aspects followed are shown in slide as legal compliance, collateral impact, safety zones, unintended consequences, training and expertise, integration with other measures, monitoring and evaluation.